Hello everyone. So let us see this problem. In this problem we have a ring and we have to find the electric field at a point which is on the axis of the ring. So let us start. A ring is, let's suppose, like this, and let's suppose this is the axis. This is the ring and the axis. Now we are supposed to find out what is the electric field at a distance x on the axis of the ring, and the radius of the ring is given to be a. So this is given to be a. This is a, and let's suppose I'm assuming this point to be some point P, and this point is, let's suppose, some point Q on the axis. So this is Q. Now given that the distance of Q from the axis, from the center of the ring is x, and we have to find the electric field for this one. So if you see that, let's suppose if I complete this, if I join these two lines, if I join PQ, it will be like this. And for a very small element, let's suppose I'm assuming a small element, and which is having a small charge dq. It is having a small charge dq. Then electric field due to this small charge will be like this. Small electric field dE will be like this. Now similarly, the electric field due to rest of the charges will be at Q, and if you see, they will be forming a triangle like this only. So if there is a point P over here, let's suppose I'm having one more point, let's suppose R. This will have its electric field like this on this line, along this line, which will be dE like this. Now if you see that for every point on the ring, you are going to have electric field, and that this electric field will be on some kind of conical shape. It will be there. It will be like a conical shape. It will be in a conical shape, and the point which we have to understand is that for every element P, there is a corresponding element R, which is going to have electric field, which so that the electric field or the triangle PQ, let's suppose this is O, and RQO will be in the same plane. So these two, the components of DE along the axis and perpendicular to axis, will be in same plane. So what I'm saying is, if I consider this angle as some angle theta, so this angle will be theta. We started with the point P, so this angle will become theta. I am vertically opposite angle. So therefore, if I assume that there's two axes, x axis and y axis kind of thing. One is perpendicular to the axis of the ring, and the other one is along the axis of the ring. So what I'm assuming x axis like this and y axis like this. Then I have to make components of DE. If I make components of DE, the DE will have a component like this: DE cos theta this way, and DE sin theta this way. Now similarly, for this was for this DE for point P. Now similarly, if you resolve the DE due to point R, it will become like this. It will be one going up. So you will be having again DE cos theta. So I will write over here. One second. Let me draw the point Q. over here. So if I draw point Q, this is let's suppose point Q, then this is point Q. Then what are X and Y axes? Y axis is perpendicular to the axis of the ring, and X axis is along the axis of the ring. Now, as I said, so DE, which I mark like this, DE due to point P, I'm calling DE, and DEP I'm calling, and the other one was DEQ or DER, sorry, for the point R, that is also going to be DE. Now, as we have seen that this angle was theta, both angle will become theta only because these two triangles PQO and RQO are going to be congruent triangles. Why? Angles are same, sides are same. Okay. Now, so what I was saying is, if we resolve this one, if we are resolving the components of each vector, I am having DEP sine theta and DE cos theta this way, P for point P, and the other one will be DE R cos theta and DE R sin theta. Now, why we have done this one? We have done this one to understand this fact that if I write the magnitude of DE, if I write the magnitude of DE, the magnitude of DE will be nothing but K dQ by R square. And what is R? R is R for DE, R will be PQ, and for DEQ, R will be nothing but RQ. Now, RQ is equals to RQ is equals to PQ. This we understand because both the triangles are congruent. So I am assuming this to be some radius R. Now, what is this radius R? This distance R is nothing but, if you see the triangle, this side is A, let's suppose this is P, this is O, this is A, this is X, we have assumed, and this is Q. So this will be R, and R will be nothing but root over A square plus X square. Now, with these facts, let us continue. So I will say that the DE, the magnitude of, since R is equal, so DE P magnitude will be equal to DEQ. So I'm considering this to be some DE, just some DE. So, and with this we understand the Y component, the Y components of DE, DEP and DEQ will cancel each other, which means because of these 2 points we are going to have, which means because of these 2 points, E net electric field will be in only X direction. Well said. So if I write E net, what is E net? So E net will be nothing but DE net will be only in X component of the electric field of each element, because Y component will get cancelled, as we have for every element we are having a corresponding element which will provide DE component which is perpendicular to the axis, and that is going to cancel. This is what we have understood so far. So DE net will be equal to DE cos of theta. So from here, if I integrate both the sides, I'm going to get this side E net and this side. What is dE? dE is k dq by r square cos of theta integration. Now we understand that k is constant and r is nothing but r is also constant. Cos theta will also be a constant. Why? As we have fixed the point Q, means we have chosen the point on x-axis, then the x will become constant for that point and the theta will become constant for that point. That is why we can consider them to be a constant and we can take it out of the integration. So we will get what? K cos theta upon r square integration dq. Once again I am saying why r is a constant. R is nothing but root over a square plus x square. Since you have chosen the point, the x, the distance from the center you have chosen, that will become a constant, and a is already a constant. So therefore r will become a constant. R will be constant for that particular point, for which we are integrating the electric field to various point charges. So this will become what? E net. E net will be integration is nothing but small summation of small charges dq, so which will be net charge q on the ring, and this will become, if I rewrite, kq by r square cos of theta. If you see cos of theta from the triangle, it is nothing but base upon hypotenuse. And what is base? What is base? Please see, base is x. Base is x, hypotenuse is r. So this will become kq, base is x upon rq. So if I write what is r, kq x upon a square plus r square 1 by 2, and we have to do cube of that thing. So E net will become kqx upon a square plus r square. Sorry, this is not r square, this is x square. 3 by 2. This will be the electric field at a point which is at a distance of x from the center of the ring, and the electric field will be along the x-axis.